Okay, so we are going to be completing the square. In class, we already talked about using algae blocks in order to visualize the concept of actually completing a square, what's missing or what we have extra, which is why it's not a perfect square trinomial to begin with, or easily factorable. We can't factor it, so we complete the square in order to mimic factoring. Now I'm going to show you the full process algebraically without algae blocks that will work for any trinomial. Our algae blocks are easy to do when the numbers are small, when the numbers are all positive, and when a is 1. When a is not 1, or if the numbers are larger, or if there is a negative involved, it can get complicated. And the steps for completing the square are as follows. So, you want to make sure that you pay attention to the fact that it can or cannot be factored. If it can be factored, don't complete the square, just factor it. But if it's prime, you have to complete the square. And the other option is using the quadratic formula, but we will do that later. So this is the same problem from the video and that we did in class with the algae blocks. You see a is already 1, and we set it equal to 0 like always. This is where it's different from the algae blocks. What I want to do here is I want to take my constant and move it over, which you see it here now. In order to do that, we do our basic algebra. We would have to subtract 3 from both sides for it to cancel on the left, and now it's on the right. Okay? That's simple enough. Again, we want to get C on the right. To get C on the right, we do it algebraically. Notice here that I'm actually dealing with the A is 1 problem, so there's nothing involved with the first coefficient. But when A is not 1, we do have to pay attention to that because you want to make sure that you have A equal to 1. Okay? So now that we have gotten C over to the right, we want to do B over 2 squared. Remember when we were completing the square with the algae blocks, we were able to take this number and we put half of it on one side and half of it on the other side. So in a sense, we took this number and we divided it by 2. Well, this number is our B. That's B over 2. Okay? With that in mind, we're always going to use B over 2 in order to find out what to put in this blank space that we've created here. Now we can think about completing the square like wanting to find out what goes in this square, in this box. Okay? And so in this case, if our B is a 4, that's what goes in this spot for B here. B is 4. 4 divided by 2 is 2. 2 squared is 4. It happens to come out the same. That's the only time when it does, when B is 4. If B is any other number, this number will vary. Okay? But this is what we're going to add in each spot here. You see now we've added in a 4 on both sides because whatever you do to one side, right, whatever you do to one side, you have to do to the other. Again, this is algebraically seeing how those numbers end up where they end up when we used algae blocks. So we have B over 2 squared ending up being added on both sides of our equation to keep it balanced. And then, of course, you always want to simplify. And here we combined our like terms and got a positive 1. All right? And so now next we want to keep going. We're going to factor. We know that normally we can think about it as 2 binomials, but because we know we're completing the square, we're in the future not even going to write those 2 separately. We're going to write them together with the squared power because it is a perfect square of a x plus 2 times a x plus 2. Those are our factors that go into the binomial squared. And to solve for x, we will take the square root of both sides. When I take the square root of the left, it cancels out the square power. That's why all I have here is x plus 2. When I take the square root on the right, I must put plus or minus in front of it. Okay, and the square root of 1 is 1. So we have the plus or minus 1 there. So now what we want to do here is get that 2 to the other side. We would subtract 2 from both sides. It cancels on the left. and we have x equals -2 plus or minus 1. Are we done? No. We can go ahead and continue to split the plus or minus so that we can do once for subtraction and once for addition, like so. And let's get straight to the point. -2 plus 1 is -1. -2 minus 1 is -3. We did the same problem in class. The same problem is on the video with the algae blocks. So you should be very reinforced on how one way or the other way both work. This is a simple problem. When a is 1, all the numbers are small and all the signs are positive. Now let's go to where that is not the case. Now we are going to do one where it's a lot more going on. We have a negative sign. We have a is not 1. We're going to go ahead and still move C to the right. And that's what you have here by adding 9 to both sides. That moved C to the right and it canceled. And after that, we have to get A to be 1. So what we want to do is divide everything by A all the way across. That 4 will cancel. So now A will be 1. 8 divided by 4 is 2. And 9 divided by 4 is not a whole number, so we have to leave it as a fraction. And that's that. That's the first step when A is not 1. That's different than when A is 1. So now that we have it like that, we're going to do our same process of doing b over 2 squared in order to determine what to add in to complete the square. Here, whatever you do to one side, you have to do to the other. So in this case, since b is 2, 2 divided by 2 is 1, and 1 squared is 1, this is what we should be adding in to both sides. Like so. Now we notice here that our 1 is not a fraction, but it's being added to a fraction, so we need to have a common denominator. So we change 1 to be 4 over 4. And now we finish all of our process for combining the like terms. We both got them over 4. 9 plus 4 is 13. Okay, and the left is still the same right now. And then because we know we did b over 2 is a 1. And so that is what our binomial is. I did not write it twice. I automatically did it squared. Now when we take the square root on the left, it cancels out the square power. When we take the square root on the right, we have to put a plus or minus. And this is what we have here. I'm pretty sure this looks crazy to you, but it'll be okay. The plus or minus must stay. The radical must cover the entire fraction. Now, at this point, we can see that there is a perfect square at the bottom of the fraction. We can simplify that. The square root of 4 is 2, so you see that now I just have 2 whole number and the radical is just at the top. The plus or minus did not disappear. Now we can subtract 1 from both sides to cancel on the left. So we have the -1 plus or minus 13 radical 2, and this is our final answer because of the radical there and the fraction there. It can't get any simpler. This is as simple as it can get. And these are 2 numbers. If we put them in the calculator, we will get the 2 different values for x. And that's it. The key is to move your c to the right, to get a to be 1, and b over 2 squared. Those are your key pieces. After that, it's all your basic algebra that you're used to. If you weren't sure about any of this, go ahead, rewind it, look over it again, pause where you need to.